Welcome to a new part of the ISM Statistics 1 exercise set, this time with an exercise on measures of dispersion. Let's take a closer look at the exercise. The points from the last math exam can be summarized as follows. What's to do with this? Calculate the range, the interquartile range, the corrected variance, and the corrected standard deviation. Okay, let's dive right into this. However, let's start with something totally different by first taking the data set and ordering it in an ascending fashion. We start with the smallest one, next smallest, and so forth until the whole data set is arranged from smallest to largest. This has a big advantage which we will directly see if we start with the first part of this exercise. First part, we were asked to calculate the range. The range, however, is defined as the difference between maximum and minimum. What's the maximum? Well, in this context, it's the largest value or the last value of our newly ordered data set. What's the minimum? That's the first value of our ordered data set. So we can directly go last value minus first value, 94 minus 16, giving us a range of 78. And the same thing in an easier fashion can also be done in the next part. Next part as well, we use the ordered data set and we want to calculate the interquartile range. For this we need the third and the first quartile. How do we get them? Well, the first and third quartile, they are also the 25th percentile or the 35th percentile. And those we can calculate by just multiplying the number of observations with the respective percentage, and the result will then be rounded up to the next largest integer if it isn't already an integer. On this, that gives us the position of the respective percentile or quartile in our data set. So here, if we take a look at the data set, we see we have 9 observations. So we multiply 0.75 with 9 and 0.25 with 9. We get 6.75 and 2.25. Rounded up to the next largest integers, this gives us 7 and 3. So we just have to take a look at 7th and 3rd position of the data set. There we find the numbers 82 and 53. And well, the difference of 82 and 53 gives us 29, and that's our interquartile range. Having thus finished the first two parts, we can go to the third part where we need to calculate the corrected variance. To start with the corrected variance, first off, we need the arithmetic mean. This, however, is gotten relatively easily. We just add up all the data points and divide them by the number of observations, leading here to an arithmetic mean of 66. This, then we use the following formula for the corrected variance, which might look complex. However, the basic thing we do here, we sum up the squared data points and correct them with the factor 1 by n minus 1. N is again 9, so we just sum up the squared data points, divide them by 8, minus the squared arithmetic mean, again with a small correction factor of 9 divided by 8. This in the end will look like this. So it's not really this complex. One just have to know that the first part basically means sum up the squared data points. If this big expression is entered into a calculator, it will result in 581. The 581 then is our corrected sample variance. Having gotten the sample variance in part C, we can just take this one and calculate the corrected standard deviation by getting the square root of this corrected variance. This gives us, for this example, a value of 24.1039. So this is our corrected standard deviation. Thus, we have finished the fourth part of this exercise and conclude the whole exercise. And I hope all of you enjoyed listening to this part and, well, gotten at least something out of it. So, until next time, see you and goodbye.